Hi everyone. The sound is okay or not? Please respond. Can you hear my voice? Anyone can respond? Can you hear my the sound? Is it clear? Can, huh? Thank you. Okay, if you have any question, you just write in chat. Huh? Okay, now I will continue with 2.3 gas pressure. Actually, for 2.2, the problem solving, you can try to answer first. That one we'll discuss in the class. So I just proceed to 2.3, okay, gas pressure. You can refer to textbook and also your notes. Okay, I'm using PowerPoint. Okay. Okay, for topic gas pressure 2.3, the first learning standard is to determine gas pressure using manometer. Second one is problem solving, calculation problem. Okay. Okay, the concept of gas pressure. Concept of gas you have studied in Form 4. How the gas pressure is produced. For example, if in a one container, the gas pressure is due to collision between the molecule of gas and the wall of container. Okay, why collision can produce pressure? Because once it hit the wall, it exerts force on the wall. Okay, the formula that you are familiar with pressure is P equals F divided by A. Okay, force per unit area means impulsive force per unit area of the wall will produce pressure. Okay, that one is the basic concept, how gas pressure is produced. Okay, so let's say for this topic, we will discuss gas pressure mean gas in a container. Okay, 2.2 we discuss about atmospheric pressure. Okay, it also involves air molecules or gas molecule, but that one is in atmospheric layer. So if the gas in the container, we discuss about pressure of the gas in the container. Okay, the instrument that can be used to determine gas pressure is manometer or U-tube. Okay, so you can see from here the arrangement. This is U-tube filled with water. It can be filled with other liquid, something like mercury. Okay, and then connect to the gas container. Okay, once the tap of this container is on, the gas will be released out. You can see the level of the liquid in the U-tube. Okay, this part will be pushed down and this part will be rise out. Okay, initially same level because same pressure act, which is atmospheric pressure. Once released gas exert extra pressure that cause level A to go down and causes level B to go up. Okay, so you can see different in level is H. Okay, so actually what is the pressure of the gas? Pressure of the gas is pressure at point A. Okay, because gas exert pressure here at point A. So this part is gas pressure. Gas pressure is pressure at point A. Okay, P gas. P gas equals to pressure at point A. Let's say we have 2 points here, same level, A and B. Same level, same liquid, same pressure. Means pressure A equals pressure B. Thus, to determine pressure of the gas means you just need to find what is pressure at B. Okay, so pressure at B is caused by what we have above the point. Above the point, we have atmospheric pressure and H meter of liquid. Depends on what type of liquid that you use here. Thus, we can determine the gas pressure as, let's say here is water. So H centimeter of water plus atmospheric pressure. So it means the total of atmospheric plus H of liquid equals to pressure of the gas for this case. Okay, so this is how manometer is used to determine gas pressure. Okay, so what we know about manometer, it consists of glass U-tube containing colored water. This apparatus is used to measure gas pressure. Okay, so if you want to measure very high pressure of gas, if the pressure is very high, so the liquid inside here, we cannot use water because it will cause very high change in H. So the length of the U-tube is not enough to support the length of H. So for that case, for high pressure of gas, we can change the liquid to mercury. Thus, the high density of mercury will cause the value of H is smaller. Okay, so we can use a very short U-tube just for the case of high pressure of gas in the container. Okay, if you have any question, just write in chat. Tulis dalam chat kalau ada soalan. Okay, so itu konsep gas pressure. Okay, we go to the next slide. This one is activity to 2.5. You can refer to your textbook. Determine the pressure of gas using water manometer, colored water. Okay, apparatus, manometer, rubber tube, half meter rule, 10 millimeter plastic syringe, materials, water, and red coloring. This one involves a very small volume of air, okay, in the syringe, so pressure is not too high. Thus, we can just use liquid colored water in the YouTube. Okay. Let's look at this activity. Cuba tengok activity ni. This is a video showing how we can change the pressure.
So I have a manometer here. Nothing too crazy. I've got an open end tube here. And you can see there's a measuring stick, and I have some fluid filled with water, but it, originally this was maybe mercury because Torricelli's earliest barometer used mercury. In any case, what I'm going to do is I'm going to take a syringe and I'm going to attach it to the enclosed tube. And now I'm going to make the space smaller for the same amount of gas that's trapped in this area. So by me making the space of the volume smaller, okay, the pressure is going to increase. So I am going to, Boyle's law, lower the volume by forcing the gas molecules into a smaller space is going to increase the pressure. The manometer is going to measure that increase in pressure. When the pressure was equal, these levels were equal, because the pressure in the inside of this tube is equal to the pressure pushing down in this open container. So the force on this liquid level is the same as the force on this liquid's level, and thus you have
of the video?
Equal pressure. Now by increasing the pressure, and I'm doing this by making the volume smaller, stuffing the same amount of gases in the same temperature and pressure, and making a smaller volume, I'm increasing the pressure. And what we can do is we can measure the difference, okay, of these liquids to measure the pressure. Right now, if I wanted to measure the pressure, if this was mercury, we would say that I'm supporting, if this is 4, and let's pretend this is approximately 23, okay, so this is 19. So from this point here, I'm measuring 19, okay, millimeters. Okay, now of course I just measured 19 centimeters. So that's 190 millimeters of fluid I'm supporting upward. And I would say that the pressure in this area is higher than the atmospheric pressure pushing down, right? Manometers use a differential of pressure to measure. So right now, the pressure in this syringe, which is connected, is 190 millimeters of mercury higher than atmospheric pressure, right? There's two forces. There's a force pushing down here and the force pushing down here. Who's winning? Clearly, this side is winning by 190 millimeters of mercury, which, by the way, is a torr. So we would say the pressure in here, if the atmospheric pressure was 760 torr, it'd be 760 plus 190, and that's how we measure the pressure here. Okay, if we go the opposite way, make them equal out again, and now I'm going to lower the pressure by making the volume larger. Whoa, how much higher in pressure is the atmospheric pressure? Well, this pressure is lowered, and this pressure on the open end is winning. Let's pretend it's also 19 centimeters. So let's make that 190 millimeters of mercury. So now the pressure in here is less than atmospheric pressure by 190. And so we would do 760 minus, okay, 190, and that would be the pressure here. So this pressure here is lower, clearly can see the atmospheric pressure is winning by 190 millimeters of mercury, okay? And again, the pressure in here is 760 minus. When we did the other side, we did what? We increased the pressure. We did what? We said, well, this is pushing back on the atmosphere, plus it's supporting the column. So this is equal to the pressure outside, but you have to add 190 to it in this case if we're going to use that. Okay, so manometers are used.
Okay, this one is also can be related to Boyle's law experiment, if you still remember. Okay, so using the shrink, inside the shrink there's air. Okay, if you push forward the piston, you can have lower volume of air. Lower volume of air according to Boyle's law. If you still remember the Boyle's law? Masih ingat ke Boyle's law? Okay, Boyle's law. Dia ada kaitan juga Boyle's law, because Boyle's law also study about change in the volume and pressure. It's about pressure. So once you decrease the volume, pressure increase. Okay, vice versa lah. Okay. So as the video show to you just now, when volume decrease, pressure increase. You can see the level on the left side will be higher than the right side, meaning pressure of the gas is greater than atmospheric pressure. Okay, for this case, like this one showing that pressure of the gas is greater than pressure of atmospheric pressure. Okay, if opposite like this, if the manometer shows direction, let's say gas in here, okay, suddenly the level here, this side, is higher than this side. Okay, gas. Okay, so means atmospheric pressure is higher than gas pressure. Or we can say P gas is lower than atmospheric pressure. So how to determine the value of pressure of the gas? If the pressure of the gas here greater than atmospheric pressure, means atmospheric pressure plus H. Okay, so P gas equals to atmospheric pressure plus H. Okay, if this one, P gas is lower than atmospheric pressure, means P gas equals to atmospheric pressure minus H. Okay, minus. Okay, jadi itu ada case dia lah. You all check the level. Okay, so this level is lower than this side, means the pressure is higher. So how to get the gas pressure? You just add H. Okay. Okay, next, the procedure of this, the experiment just now. This is the one sample of data collected. Push the piston slightly into the shrink until reading 8 milliliter. Determine height H between water level in both arms. Calculate air pressure in meter of water. Use atmospheric pressure 10 meter of water. Kita dah discuss ni kan, atmospheric pressure dalam unit meter of water. Repeat step 2 and 3 reading of with reading of 6 millimeter, 4 millimeter of the shrink. Okay, so for the 8 milliliter, the height H 0.06 meter. Okay, 6 centimeter. For the 6 milliliter, the reading become 10.5 centimeter or 0.105 meter. Okay, 4 millimeter of the volume of air, we get 0.150 meter. So what is air pressure? Just now mentioned already, atmospheric pressure plus H. So from here, 10 meter water plus 0.06. So we get 10.06. Okay, this one, 10 meter water plus 0.105. So we get 10.105. Okay. And then the last one, 10 meter water plus 0.15, 10.150. Okay. So what we get from here? When volume decrease, pressure increase. Okay. So this experiment also can be done to show relationship between pressure and volume for Boyle's law. Okay, setup of apparatus same setup of apparatus. Okay, let's look at some question below. How can the value of air pressure from this stated activity stated in Pascal? Means you want to convert meter of water to Pascal. So just use the formula P equals H rho G. Okay, so the total pressure here is atmospheric pressure plus H. That's why here we have H plus 10. Okay, for this activity. Okay, so H is height between the water level, rho is density, G is gravitational acceleration. Okay, so we can convert to Pascal. Okay, you can calculate here, you can put one more column here, calculate in Pascal. Suggest a suitable liquid to be used for measuring higher gas pressure. Okay, I did mention earlier. Okay, so if we use liquid such as water, low density, so just suitable for low pressure of gas. If the pressure is too high, water is not suitable. Then we can change it to higher density liquid such as mercury. Okay, so mercury is suitable because of higher density liquid. Okay, let's look at some problem solving. Okay, some problem solving here. A mercury manometer connected to mercury manometer connected to flask compressed gas, given atmospheric pressure in unit cm mercury, density of mercury, and gravitational acceleration g. Okay, we look at the diagram. This is a gas in a container, and this one is the manometer is mercury. Okay. What is the pressure of the compressed gas in cm mercury? Okay, so we apply the concept. Actually, A is here, A, and here is B. Okay, same level, same liquid, same pressure. We apply the same concept. Okay, so what is pressure of the gas? Pressure of the gas equals to pressure at A. And pressure at point A equals to pressure at point B. So we can say pressure of the gas equals to pressure at point B. Okay, pressure at point B is caused by everything above the point. So this arm is open. Open to air means there is atmospheric pressure. Okay, and then the difference in level A and B here, 40 centimeter. Means above point B is an H centimeter of mercury. Thus, what is gas pressure? H plus atmospheric pressure. We can just add straight away because the liquid is mercury and the centimeter. Atmospheric pressure also given in centimeter mercury. Thus, we can just add 40 plus 76, 16 cm mercury. Okay, so we get in unit cm mercury, the gas pressure, which is equals to pressure at A equals to pressure at B. Okay, next, calculate gas pressure in Pascal, means change the unit from cm mercury to Pascal. We apply the formula P equals H rho G. So in this case, H is 116 centimeter. Okay, 116 centimeter you change to meter. So one mercury, liquid use mercury, so density of mercury, G0.81. So we get the answer 1.55 times 10 to the power 5 Pascal. Okay, so this one in unit Pascal. Okay, will your answer in A and B change if the glass tube of the manometer has larger diameter? What do you think? Can I have a response for this one? If you use manometer with larger tube, does the reading that you get or pressure of the gas change? Anyone can respond? Yeah, Kong Yang Hui? Yes, anyone can respond? Same Chen Wei. Remains the same. Yeah, Chen Wei. Yes, correct. Yeah. Why same? Berubah. Why remains the same? Concept? Pressure does not depend on area. Pressure in liquid does not depend on area. Okay, shape, size. Okay, just depends on side height same lah. Just discuss about diameter. Yeah, correct, Wang Sun Jian. Pressure is not depends on surface area. Okay. Okay, no change because pressure in liquid and atmospheric pressure does not depend on area or shape of the tube. Okay. Okay, look at example 2. Mercury manometer used to measure pressure in airflow pipe. What is difference between air pressure in the pipe and atmospheric pressure in cm mercury? Okay, look at here. The difference in level 25 cm. If atmospheric pressure 75 cm mercury, what is air pressure in the pipe in Pascal? So information given is density of mercury and gravitational acceleration. Okay, difference in pressure equals to height of mercury column. Okay, difference in height of mercury column. Ataupun difference in level. Boleh juga difference in level. Okay, equals to 25 centimeter mercury. Atmospheric pressure 75 cm mercury. Thus air pressure in the pipe. Okay, the air pressure you can see from here, gas pressure or air pressure is greater than atmospheric pressure because this level is lower than this one. So air pressure is higher. Thus the air pressure in the pipe equals to atmospheric pressure plus 25 cm mercury. So we have 25 plus 75, which equals to 100 centimeter
mercury. Okay, be careful, check the question. They want you to state in Pascal, so you apply formula H rho T. So in this case, H equals to 100 cm, change to meter is 1 meter. So 1 times density of mercury times G, so we get 1.33 times 10 power 5 Pascal. Okay, for this case.
Okay, any question write in chat. Tulis dalam chat. Okay, formative practice 2.3. I want you all to try to answer. Okay, if I can discuss it now. So then you can write in your books lah, exercise book. Okay, formative practice 2.3, figure 2.21 shows water manometer connected to flask containing gas. Okay, compare the gas pressure in the flask with the atmospheric pressure. Okay, compare, perkataan compare sini. Okay, state the difference between gas pressure and atmospheric pressure in meter of water. You all kena familiar dengan unit-unit. Given gravitational acceleration, atmospheric pressure, also given in meter of water. Okay, so solution. If this level is lower, means the gas is the winner. Maksudnya gas pressure lebih tinggi lah. It able to push down this level lower. So pressure of the gas is greater than atmospheric pressure. Okay, tulis dalam bentuk compare word. Gas pressure is higher than atmospheric pressure. Okay, B. B. The difference between gas pressure and atmospheric pressure equals to difference in level, okay, of coloured water or level of water, which is equals to 36 cm of water. Okay, sebab ini water, ini dia guna cm, so 36 cm of water or 0.36 meter of water. Means gas pressure is 0.36 meter water greater than atmospheric pressure. Okay, so gas pressure equals to 0.36 plus atmospheric pressure 10.3 meter of water. So 10.66 meter of water. Then if you want you to convert to Pascal, use H rho G. Okay, H rho G. H rho G. So H is 10.66, rho is 1000, G is 9.81. So you get 1.04575 Pascal. Or you want to write in standard form, 1.05 10 to the power 5 Pascal. Okay, ini example in the textbook. Okay, ni dalam buku teks. Boleh tengok balik dan balik buat sendirilah. Okay, saya nak you tulis semula, saya dah explain, you tulis semula. Okay, number 2, what are advantages of using mercury barometer compared to water manometer? Okay, so for mercury manometer, due to higher density, for a larger change in pressure, it just causes a smaller change in height of mercury column, okay, due to its higher density. So it can measure higher pressure because mercury is denser liquid. Does not need a very long tube. Okay, tak perlu panjang. Okay, kalau water kena panjang. Rate of evaporation of mercury is lower than rate of evaporation of water. Okay, kalau water you leave it for, okay, leave it for some time. After that, you can see the amount of water will decrease. Okay, so you need to add some more. Okay, but for mercury, no. Okay, because of rate of evaporation is very low. Okay, itu advantage why we choose manometer that using mercury. Number 3, a mercury manometer is connected to steel cylinder containing compressed gas. The pressure of compressed gas and atmospheric pressure are given
respectively. Calculate difference in height between two mercury column in manometer. Okay. Can you imagine what is mentioned from here? Ini ialah pressure of the gas, ini ialah atmospheric pressure. Okay. Calculate difference in height between two mercury column. So difference in pressure between compressed gas and atmospheric pressure equals to 180 minus 101, which is equals to 79 kilopascal. Unit is kilopascal. Change to Pascal is 79,000 Pascal. The difference in height, okay, is equals to this pressure. Now we want to find H, the height. Okay, apply formula P equals H rho G equals to 79,000. Okay, we want to find H. Okay, so H multiply density of mercury multiply G equals to 79,000. So you get H equals 0.592 meter or 59.2 centimeter. So the difference in height of two mercury column equals 59.2 centimeter. Okay, so means we are playing with the formula. Formula P equals to H rho G because the liquid is used in the manometer. That's why we use the formula pressure in liquid. Okay, do you have any question regarding this one? Ada soalan? Do you have any question? Sini semua tak boleh dengar suara Okay, write in comment kalau ada soalan. Ada soalan? Okay. If no question, I will go to the notes. You boleh refer buku nota. Gas pressure. Okay. Okay, to the notes. 2.3 gas pressure. We can try to answer some of the question in the books. Untuk S4 nanti saya akan belum sampai lagi lah yang topik atmospheric pressure, tapi tak apa. Sebab tu saya tak panggil semua datang. Kalau you all nak join, boleh join je. Okay, you look at page 9. Page 9, gas pressure. Okay, saya nak sambung ke sana kalau tak ada soalan. Okay, ni dalam notes you all. Okay, gas pressure can be measured using manometer, YouTube. Look at situation. Before connected to gas supply and after connected to gas supply. Okay, before same level, okay, same level because same pressure. Okay, let's say kita ada point A, point B. So means pressure at A equals to pressure at B equals to atmospheric pressure. Okay. Okay, once you let the gas gets into the manometer, this one, gas flowing here. So pressure of the gas equals to pressure at A equals pressure at B. Okay, concept here. What is pressure at B? What we have above the point, everything above the point. Okay, everything. Okay. So if this part is open, mean there is atmospheric pressure. If closed, no atmospheric pressure. Okay, this one open to air, so there is atmospheric pressure. So atmospheric pressure plus pH. Okay. So P gas. Let's say this one is H. So P gas equals to atmospheric pressure plus H. Okay. So look at some exercise on this. Cuba soalan. Okay, so I give you 5 minutes. You can try. 5 minutes. If you have done and you have the answer, you can comment, write in comment. Okay, number 1, a compressed gas is connected to mercury manometer. Calculate difference between gas pressure and atmospheric pressure in cm mercury. B, gas pressure in cm mercury. C, gas pressure in Pascal. Wang Sunjian, 12 cm mercury. Okay. Pelajar yang lain macam mana? 5S1. Semua tidur ke? Okay, I can see answer from Wang Sunjian. Okay, we can go through this question. Okay, A. The difference between gas pressure and atmospheric pressure. So this one is the gas. Okay, and here is atmospheric pressure. Okay, so the difference between pressure of the gas and the atmospheric pressure is equals to 12 cm mercury. Or we can write, if you want to write the step of calculation, the difference is atmospheric pressure minus pressure of the gas. Okay, something like that. So equals to 12 cm mercury. Sorry, terbalik sekejap ya. No, pressure of the gas minus pressure of the gas is greater. The gas is greater than wait. Okay, so we can say P gas minus atmospheric pressure. So we get 12 centimeter. The gas pressure in cm mercury. So P gas equals to atmospheric pressure plus H. Okay, so atmospheric pressure, use the value given. Sometimes they give you 76, sometimes 75. Depends on the information given. 76 plus 12. So we get 88 cm mercury. Okay, and then you want to convert to Pascal. P equals to H rho G. H is 88 cm. Convert to meter, 0.88. Density of mercury, 1.36 times 10 power 4. Multiply G, 9.81. Okay, 1.17 multiply 10 power 5 Pascal. Okay, yeah, correct. Wong Sin Jian. Okay. Okay, we'll look at question number 2. A compressed gas connected to mercury manometer. Gas pressure 85. What is value of H? What will happen to the value of H if mercury replaced with water? Ini jenis soalan HOTS. Soalan predict. Okay. So this side, pressure of the gas. This one, atmospheric pressure. This arm must be open. Kalau close, tak ada atmospheric pressure, mesti open. So what is value of H? H equals to P gas minus atmospheric pressure. So we get equals to 85 minus 76. This we get 9, is it 9? Yeah, 9 cm mercury, the pressure. Or we can say the value of H equals to 9 centimeter. Okay. B, what will happen if mercury replaced with water? Apa berlaku? What happened? What happened if we replace mercury with water? Okay, Wang Sun-Jian, increase. How about the rest of you? Are you all still with me? Edwin? Okay, correct, yeah? H increase. Okay. Okay, last time in the topic atmospheric pressure, I also showing the relationship between density and height, okay, of liquid level for U-tube or manometer. Okay. Jangan tulis simbol macam ni ya, tulis increases lah. Okay. Increases. Okay. Kalau dia minta you explain, macam mana nak explain? Okay. The lower the density of liquid, okay, the higher the level or height. Okay. Relationship density dengan H inversely proportional. Okay, denser, H shorter. Okay, ini yang dah belajar sebelum ni konsep ni. Okay, so that one is for topic gas pressure. Okay, another device that can be used to determine gas pressure is Borden gauge. Borden gauge. Okay, ini you akan dah pernah lihat lah masa form 4 kan. Okay, kalau tak ada soalan means we have done for topic gas pressure. Dah habis dah topik gas pressure. Okay. Any question? Ya, ada soalan. Okay, so today saya nak sambung lagi dengan topik Pascal Principle. Pascal Principle sebab ada bangsa lagi. So I continue with Pascal Principle. Pascal Principle also is quite short, the concept, but for the application is quite long lah, but I just go through the main part, main topic, main concept for the Pascal principle. Okay, so I will refer to the PowerPoint again. Saya akan rujuk PowerPoint untuk Pascal principle. Okay, later I will share the PowerPoint with you all. So actually my video also got for this topic sama saja the same PowerPoint in YouTube. Okay. Okay. Okay, Pascal principle. First part 1. Okay. So for this one, I will discuss two learning standard. The first one describe principle of pressure transmission in an enclosed fluid. Second, communicate about hydraulic system as force multiplier. Okay. Mungkin dalam another 40 minutes or 45 minutes I will stop. Okay. Okay. So 2.4 Pascal principle actually discuss about principle of transmission of pressure in a closed fluid. Okay, when we talk about fluid, it can be liquid, it can be gas. Okay. I hope you can see. Okay, principle of transmission of pressure in a closed fluid. Okay, when we talk about fluid, okay. Okay, when we talk about fluid, there are two types of fluid yang kita akan lihat. Okay. Fluid kita akan lihat gas. And okay. So transmission of pressure in a closed fluid refer to either gas or liquid. Okay, sama ada gas or liquid, we call it fluid. Anything that can flow, we call it fluid. Okay. Okay. You can see the water rush out. You can see the level of the hole at the same height or same depth. So what is your observation on the flow of water out of the hole when Pascal piston is pushed inward? Explain your answer. This one is for this one. Okay. If you look at the video earlier, why the water can spurt out from the hole? Okay, kenapa water boleh keluar? Okay, the water spurting out because there is pressure that cause the water to spurt out. Okay, so pressure act same pressure at all the holes here because all holes here at same height. Height dia sama ataupun depth same. Okay, same depth, same pressure. So water rushing out at same speed. So poke some hole. Okay, and this one is piston. Apply force when the piston is pushed. Okay, water cannot be compressed, thus it will coming out from the holes here, spurt out. Okay, so what is your observation on the flow of water out of the hole when the Pascal piston is pushed inward? Explain your answer. Okay, So what happened is the piston is pushed. The action of pushing, actually, you apply force on the surface of water. Apply force on the surface of water means produce pressure. Okay, so pressure acts at the surface of water. The pressure is transmitted throughout water in all directions. So pressure exerted here, P equals to F over A, equally direction. Then cause the water out at same speed. So from here, we can see the pressure that acts on the surface of water can be transmitted. Boleh dipindahkan. Itu equally. Okay. That's come the Pascal principle. Okay. So that one explain Pascal principle, which states that pressure applied on an enclosed fluid is transmitted uniformly ataupun equally, okay, in all direction in the fluid. If you discuss about liquid, you can say in all direction in the liquid. Okay, so ini ialah Pascal principle. So Pascal principle is principle of transmission of pressure. Okay, in a closed fluid means liquid in a closed container. Okay, bekas yang bertutup means no in or out. Okay. Okay, now we look at the hydraulic system as a force multiplier. We still apply the same formula, E equals to F over E. So the force, okay, F equals to PA. Okay, according to Pascal principle, pressure applied on the surface of liquid transmitted uniformly throughout liquid. If this pressure is transmitted to larger surface area, what is the effect on force produced on the surface? Okay. Pressure equals to F over A. Thus, force equals to pressure multiply area. If the area increases, okay, means produce also increases. Okay, look at this one.
Here it's no problem at all to slow down a vehicle using only leg power. In modern vehicles, however, pure muscle power would not suffice. Here the driver is supported by the vehicle's brake system with brakes at the front and rear axles. Pressing the brake pedal slows down the vehicle. The vehicle's brake system employs hydraulics. This means that a force is transmitted via a liquid. The principle is based on a closed system with pistons, cylinders, and a special liquid. But how does it work? Liquids have one very special physical characteristic. They're incompressible.
They're not decompressed. Incompressible liquid.
Unlike air.
Kalau air boleh compress.
That's why hydraulic systems must be free of air. Within a hydraulic system, pressure is exerted on a liquid. By means of this force, the space within a cylinder is reduced and the liquid is displaced. The resulting pressure acts the same at any point in the system, retaining its magnitude. If two cylinders of equal size are connected to each other, the liquid transmits the exerted force while maintaining the ratio. What does that mean for a vehicle? The foot exerts a force on the brake pedal. It sets the brake fluid within the brake master cylinder in motion. The fluid is forced through the connected tubing to the wheel brake cylinder. The exerted force is thus transmitted.
Okay, so kalau you lihat tadi ya, toy car tadi ya. Okay, the small girl just uses her leg to stop the car. Okay, but if you drive a real car, the engine car, you need to step on the brake pedal to stop the car. Impossible, you use leg just to stop the car. Because at high speed, okay, you need a greater force to stop the car. So that one will apply the principle of transmission of pressure using liquid, okay, which is Pascal principle. Okay, later we discuss more on this brake system of the car. Okay. So for this one, a small force on a small area of piston produces larger force at larger area of piston. Okay, activity 2.7. Let's say we have this model hydraulic system, simple hydraulic system. Okay, there are two shearing, large piston, small piston, okay, connected to using you can look at video in bahasa Melayu. Look at here.
Model sistem hidrolik ringkas terdiri daripada sebuah picagari kecil
Small string,
dan sebuah picagari besar.
bigger string,
Kedua-dua picagari itu disambungkan dengan tiub silikon
silicone tube.
dan kedua-dua picagari diisi dengan air
Inside there's
sehingga
water,
aras yang sama.
same level.
Dalam picagari kecil terdapat ombor kecil
The small
dan
piston,
untuk picagari besar ada ombor besar.
large piston.
Sekiranya kita letakkan
Okay,
pemberat
place
berjisim
50
50
gram
gram
sorted
di
weight.
atas ombor kecil. Berapakah jisim yang perlu diletak di atas ombor besar untuk mendapat imbangan?
So that the level remains the same. If you
Perhatikan
put on the
bahawa
small piston
Di
50
atas
gram,
ombor besar,
you just add more load
jisim ialah 150
until the level
gram.
becomes same.
Ini bermakna pemberat berslot 50 gram di atas ombor kecil boleh mengimbangi slot 150 gram di atas ombor besar. Dan perhatikan pula, kalau kita letak pemberat berslot yang kecil, dia boleh menggerakkan pemberat.
Okay, it means a small force that you apply on the small piston able to move, okay, a larger piston with larger load. Okay, nampak Just now you put a 50 gram, 50 gram here, and then add 100 become equal. Okay, so means at gram it plus 100 gram at our distance. Okay, so this one showing that input, this is input force. Input force smaller, able to produce output force, which is large. So this concept is applied to hydraulic system that also has force multiplier. Okay, dia menggandakan force. Contoh sini, kalau ini ialah 5 Newton, dia hasil 50 Newton. Okay, 100 Newton produce 1000 Newton. So that's why we call it force multiplier. Okay, this one is the hydraulic system, a simple system. Okay. If we have time, then I will show you, because we have only one set in the lab. Okay, so what is hydraulic system? Apa tu hydraulic system? Okay. Hydraulic system consists of two piston. Okay, ada dua piston. Small piston and larger piston. Okay. Macam kita panggil tadi shearing, macam shearing tadilah. The liquid used is incompressible liquid. Okay, tidak boleh compress, means the volume is constant. Incompressible maksudnya constant, volume tidak berubah. Okay, characteristic of the hydraulic fluid are. Okay, ini soalan essay paper 2. Contohnya, modify, okay, a hydraulic system to produce greater output force and efficient. Okay, so the characteristic of hydraulic fluid, we can have high boiling point. Why we need high boiling point? Because you can see for the hydraulic system, the liquid keep always push down and push up here. Okay, so it means it keep moving and rub the wall of the container. So means it will produce heat energy. Heat energy, that one will cause the temperature, okay, of the liquid to increase. So if we use a low boiling point, we're afraid that the liquid might boil. Okay, so we use high boiling point liquid so that it does not easily boil. Okay, low rate of evaporation, so that the volume of liquid no need to be at a time to time, means the volume remains the same in the hydraulic system. Okay, does not form bubble. Okay, there's no bubble in the liquid. Once there is bubble, the pressure will be transmitted no longer uniformly, because some of the pressure will be used to compress the bubble. Okay, so we don't want bubble exists in the liquid. Okay, low rusting effect. Okay, pipe does not get rusty easily. Okay, normally the pipe is made of metal, so we use a liquid which does not cause rusting to the pipe. Okay, so the pipe itself also is made of material which is low rate of rusting, like stainless steel, okay, PVC. Okay, contoh lah. Pipe does not get rusty. Low hydraulic flow smoothly in the pipe. Okay, the liquid also low density. Okay, based on this characteristic, can you relate all these characteristic to one type of liquid? Okay, kalau tengok semua ni ini karakteristik yang ada pada apa? Okay, not water. Okay, oil lah. Okay, that's why in the hydraulic brake system, kita ada oil brake, kita tak ada water brake kan? Oil brake. Brake kereta. Okay, ada oil brake. Sebab oil ni incompressible liquid, high boiling point, low rate evaporation, does not form bubble, but longer period must go for service lah. Okay, pun kena service juga, check takut ada bubble.
Okay, low rusting effect, low density. Okay. Okay, how it works. According to Pascal principle, pressure applied on the sea throughout liquid. In one. Apply F1 here, input here. Pressure produced is P1, F1 over A1. A1 is area of this piston, area of this piston, A1. Okay, A2 is area of this piston. Okay. Pressure that produced here, P1, will be transmitted through liquid. Okay, transmit to here. Okay, P1 multiply A will produce F2. Pressure transmitted here multiply area 2 produce 2. Thus, from this relationship you can see the larger the area of the second piston, the higher means the force produced here depends on area of F2. You just increase the area of the piston A2. Another method is increase F1, which is higher. Thus, force produced also higher. Okay. Pressure transmitted P1 actually equals to P2. Okay, piston 1. Because of the concept to P2. Okay, dari sini ya. P1 equals to P2. P1 is F1 over A1. P2, F2 over A2. So from here, we can make F2 as the title of the equation formula. F2 equals to ratio of area of piston A2 over A1 multiply F1. So what is this A2 over A1? Ratio of piston. This one represent multiplying factor. Okay, let's say area of piston here is 10. Area of piston here is 2. So what we get for the output force for F2? 10 divided by 2 times F1. So it becomes 5 F1. So A2 and A1 means multiplying factor. Or we can say the force produced is 5 times greater. 5 kali. That's why we call it multiplying factor. Okay. So dari sini you boleh nampak lah dia punya pesan dia. So you want to increase the increase the multiplying factor. How to increase multiplying factor? Increase A2 or you can decrease A1. Okay, jadi perbezaan yang besar dari segi area of piston. This one will increase the output force. Okay. Ada soalan tanya ya. Okay, so ini dipanggil Pascal formula. Pascal formula. Okay, application sedikit. Application of Pascal principle, ini activity 2.7 shows that force acting on small piston can produce larger force on the second piston. Okay,
This shows that hydraulic system not only transmit pressure but also multiplies force. Okay. Okay, formula dia dari sini you nampak. F direct proportional to area for constant P daripada formula ni. Okay, pada formula ni. Okay, ini adalah hydraulic brake system.
What does that mean for a vehicle? The foot exerts a force
Okay,
on the
apply
brake pedal.
force at the brake pedal. You tekan minyak.
It sets the brake fluid within the brake master
Dalam tu
cylinder
ada
in
oil
motion.
brake. Oil brake akan transmit through the pipe.
The fluid is forced
Okay,
through the
nampak tak?
connected tubing
Semua
to the wheel
connect to
brake
the wheel
cylinder.
brake cylinder.
The exerted force is thus transmitted.
Liquid dia transmit. Okay, nampak tak ada pergerakan kan? Brake dish, brake drum.
This principle remains the same even if more than one wheel brake cylinder is connected. The force continues to be transmitted uniformly.
Ini konsep yang
However,
sama.
it's divided into 4 equal parts, proportionally reducing the distance moved by the pistons. In a vehicle, this is called a single-circuit brake system. For increased safety, the system is separated into 2 circuits. Depending on the vehicle concept, the brake system acts separately on the front and rear axles, or in a diagonal direction. This provides increased safety in case one brake circuit should fail. A hydraulic system not only transmits forces, it also
Tadi car
multiplies
brake
them.
system. Ini ialah
For this to
hydraulic jack.
happen, the operating piston's diameter must be smaller than that of the working piston.
Ini car brake system nampak tayar kereta depan belakang. Okay, so this one showing how the liquid, the pressure throughout the brake system until able to stop the car. Okay. Second ialah ini hydraulic jack to lifting heavy loads by application of smaller force. This is also Pascal principle. Okay. Guna tangan saja untuk gerakkan dia naik turun, then it able to lift the car, very heavy car. So apply the concept of force multiplier. So for application, I will discuss more when in the class. Sebab banyak saya tak explain penuh lah. I will explain more in the class. Now I want to go to the notes, but now it's already 3:30, sudah 3:30 kan. Okay. So we go to notes. Nota. Okay, Pascal principle. Pressure applied on enclosed fluid transmitted uniformly or equally in all directions in the fluid. Fluid sini is either liquid or gas. Okay. Hydraulic system uses liquid to transmit pressure. Hydraulic system can act as force multiplier. Okay. So this is simple hydraulic system. Input part, input piston, smaller area. Okay. Output piston, larger area. So inside using hydraulic fluid. Okay. Pascal principle, when apply force at the input piston, it will exert pressure P1 equals to F1 over A1. Okay, the pressure P1 will be transmitted equally throughout liquid until reach here. Okay, pressure acts at the second piston P2 actually equals to P1. Okay, pressure at P2 equals to F2 over A2. Okay, so according to Pascal principle, P1 equals to P2. So we get this equation. So this equation is the equation or formula for Pascal principle. From here we get F2 equals to A2 over A1 multiply P as well. Yeah. So we have F2 equals to A2 over A1 multiply F1. Okay, so we can see from here A2 over A1 is multiplying factor. Okay, nah, itu ialah formula untuk Pascal principle. Okay, you can read through yang bawah tu. Application, kalau ikut dalam notes you all, very simple. Okay, you can refer to textbook page 63. Kita ada hydraulic jack, hydraulic brake, yeah. Handle is pushed up and down repeatedly, not once only, repeatedly. So you will increase the large piston to lift up the load. Okay. For the hydraulic brake, step on the brake pedal. Okay. The liquid will be transmitted to pipe. We have master cylinder and slave cylinder. Ataupun slave piston. Okay. So the liquid will cause the brake drum to be pushed or to be the red color brake shoes. Okay. The yellow color is the oil or brake fluid. Okay. So it will push the piston so that the brake shoes will move closer or compress to the drum. Okay. So this one will produce friction that able to stop the car. Okay. Same thing here, brake pedal, master cylinder. Okay. Okay. The piston is pushed. Okay. Close to the brake shoes. Ini daripada depan, ini daripada sisi brake shoes. And then produce friction that able to stop the car. Okay, so ini ialah hydraulic brake and this one is hydraulic jack. Jadi ada dua application di sini. Okay, exercise. We just discussed this one. This is input. The small one is input. The bigger one is output. Okay, you can just put it as F1, F2 here. This one is A1. This one is A2. Okay. A, compare pressure at A and B. Compare pressure A and B means pressure at A equals to pressure at B. Calculate multiplying factor. Multiplying factor is A2 over A1. 2.5 divided by 0.5. Check the unit. Means 5. No unit. 5 times. C. Calculate F at output piston. Means F2 equals to 5 F1. Multiplying factor, multiply input force. 5 times 100. So we get 500 Newton. Okay, number 2. Diagram shows hydraulic system that is balanced when load X and Y are placed on piston A and B respectively. Given area of piston A is 3 times bigger, piston A than B. Okay, yang smaller ni input. Okay, smaller input, bigger ialah output. Ingat tu je. Okay, smaller input, bigger output. So normally for the input we put A1, output A2. Okay, F1, F2. Okay, so means A2 equals to 3 times A1. Weight of X, F2 is 30 Newton. So what is Y? F2, 30 Newton. What is F1? Okay, so formula tadi, we apply the formula. F2 equals to multiplying factor A2 over A1 times F1. So what is A2? 3 times A1. Okay, so boleh cancel A1. So we get F1 ataupun Fy pun boleh juga. F1 equals to F2 divided by 3. Means 30 divided by 3, 10 Newton. Okay, so means input 10 Newton, produce output 30 Newton. Okay, so be careful. Normally yang input is the small one, small area ialah input, larger area output. Okay, to be able to produce larger output force. Ini pun ialah seperti. Okay, what modification can be done on the surface area of the input piston, surface area of the output piston, force applied on the input piston to produce larger output force. Okay, so for this one, guna je formula ni, F2, A2 over A1, F1. Okay, if you want to increase F2, means you must change these 3 factors. Okay, so area of input piston must be what? Ini inversely proportional A1 dengan F2. Jadi you kena kecilkan. Okay, area, surface area of the input piston decrease. Okay, surface area of output piston increase. Force applied on input piston, F1, increase. Okay. So decrease, increase, increase. So this one based on the formula only, ikut je formula. Okay. Number 4. The hydraulic fluid used for jack contains some air bubble. That's why oil brake kena pergi service. Tak boleh sampai 20 years guna kereta tak pernah service. So that one is very dangerous. Why? Maybe there's a bubble form in the oil brake. So the brake will become less efficient. Okay, very dangerous now. Sometimes will cause accident. Okay, so hydraulic fluid used for the jack contains some air bubble. The bubble, air bubble, you can see the white color air bubble. Explain effects of the presence of the bubble on efficiency of the jack. What happens if there is bubble? Can you respond? Does the efficiency increase or decrease? What happens to the car? Can the large piston lift the load or not? Boleh tak? Apa effect dia? Anyone can give a response to this? Okay. No. Remember the characteristic of the liquid that we use in the hydraulic system must be incompressible. Why we want it to be incompressible? Because pressure will be transmitted uniformly. Or equally. Okay? Yes, correct, Edwin. Air bubble is compressible. So once the air bubble compressible, if the pressure transmit, okay, from here, pressure transmit, let's say P1, okay, transmit from here is 100%. Okay, let's say when reach the bubble, maybe the first bubble will take 1%. Okay, this one 2%, 2%, 1%. Okay, so it means loss along the way already 6%. So when reach here or reach the distance here, maybe it's only 94%. Okay, 100% there is loss in the pressure due to the air bubble because air bubble is compressible. Thus, the pressure no longer transmitted equally. Okay, so pressure no longer transmitted equally, F equals to PA. If the pressure is decreased, means the output force will be decreased. Means expected amount of load that can be lifted here will become smaller. Means cannot be lifted up. Okay, no longer efficient or less efficient. Okay, so you can write down some of the effect. The presence of the bubble, pressure, not transmit uniformly throughout liquid. Means pressure 2 is not equal to pressure 1. Output force decrease. Okay. Okay. So means the hydraulic jack is not efficient or less efficient due to loss in pressure to compress the air bubble. Okay. Okay, so for this topic, Pascal principle, I just end it here. I will continue for the activity and application for the application of the Pascal principle. So means I need you all to continue with the exercise, formative practice. Just now for the topic of gas pressure, we have 2.2. And then for Pascal principle, we have 2.3. Okay. If you have any question, just write in chat. Ada soalan? Okay, so you all boleh continue dengan formative practice 2.2 and 2.3. So I think that's all. Okay, for if you have if you want to ask more question on this, just write in Telegram, class Telegram. Okay, so that's all for now. Thank you for joining me. Okay, bye. Welcome.